All right, let's play with Hive, and feel free to follow along here. I encourage you to do so. I've already spun up my virtual machine here with my little Hadoop instance on it, so go ahead and do that. Press pause if you haven't already. And we're going to pull up Ambari on port 8080 of 127.0.0.1, as we've done before, and sign in. All right. Now you might remember from the very first lectures in this course that we actually started off with looking at Hive, just as sort of a way to dive in and make sure that Hadoop was working. So we're going to do something very similar here with a little bit of a twist. We're again going to use Hive to analyze the movie lens data, and to keep it simple, just to keep things accessible here and simple to start off with, we're going to do the same thing we did back in lecture 1, where we're going to just find the most popular movie in the movie lens data set. Little twist though, we're going to actually print out the name of that movie now instead of doing it the hard way and looking up those movie IDs by hand. So to get started, go up to the view icon here, the little grid, and select Hive View. And it will run some service checks, and you should be seeing something like this, where we have an interactive query editor, and we can just start typing in SQL commands here. But first, we need some data to actually query. So you might still have some remnants from lecture 1 of this in there. So if you open up the databases here and select default, if you see ratings in there back from lecture 1, go ahead and get rid of that. You can do that by just typing in drop table ratings and then hit the execute button here, and that should get rid of it. So again, if you see ratings here and you're following along, get rid of that by doing a drop table ratings command. And already you're seeing how you can just use standard SQL commands with Hive to do pretty much anything you want. After you do that, you'll have to hit this little refresh database icon here to actually see that that's gone from default. So at this point, you should be seeing something like this. So let's go ahead and upload our data into Hive. To do that, I'm going to go to the upload table tool here. Now you could do this from a command line as well, but let's do it the easy way, huh? Why not? Now, we happen to know that the movie lens ratings data is in a tab delimited format, so I don't actually want comma separated values, I want tab. And to do that, I'm going to click on the little settings icon here, and I'm going to change the field delimiter to a tab character, which is ASCII value 9. And I'm going to choose the file from my local file system, so that's going to let me upload it right from my PC. And if I go to my downloads folder where I actually downloaded the movie lens dataset originally, somewhere in this mess of my downloads there should be an ml-100k folder. There it is. And if I go in there, I should find u.data. So let's go ahead and open that up and import it. We're going to give this table a name. Let's call it, how about ratings? That's creative. And we'll give these columns some appropriate names as well. We know this script represents the user ID, the movie ID, a rating, and we're going to call this epoch seconds because technically that's what it is. It's the timestamp for when the rating was done. We're not actually going to use that, so it doesn't matter. Now it inferred the types to be integers, and those are our appropriate types here. You can see that there are other data types you can choose from in Hive. Tiny int, big int, boolean, float, double string, binary, all the usual suspects. So you don't have to use ints if you do have other kinds of data, string being a common one. And now that we have that, we can just go ahead and upload it if everything looks right. So, just give it a quick look here and make sure that it looks reasonable. Yes, we have user IDs, movie IDs, ratings, and timestamps. So go ahead and import that puppy. And it'll take about a minute to come in. All right. Now, I also want to be able to display the names of these movies without looking them up the hard way. So let's go ahead and import the names, the u.item file as well. So we know that this one is actually separated by pipe characters. So I'm going to go change my delimiter to a pipe. That's ASCII character 124. And upload that from our local file system as well. This time I'm looking for u.item. That contains the mapping of movie IDs to movie names, among other things. We'll call this table, names. And all we really care about are the first two columns, so we'll call that movie ID, just to be consistent with the other table. And we'll call that title. And I don't care about the other ones, just let it call it whatever it wants. And we'll go ahead and import that as well. All right, so now if we go back to the main Hive view here, and we click on the refresh icon on our Database Explorer, we should see under default a names and a ratings table. How about that? So the structure here is we have a default database that we're using. We could have typed in create database, some other database name, and use that database name just like you would in SQL. But just because we're messing around here, let's just keep it in default for now. So we have names and we have ratings now. Woohoo! And if you can open those up to actually take a peek at the schema, make sure that it looks right. Looks right to me. So now we can start playing with it. Let's do it. All right, remember we talked about views in Hive. So we can kind of break up more complicated queries into parts using views. So the idea is that we're going to create a view that's actually going to find the most popular movie ID and then query that view, join it with the names table to actually print out the names of the most popular movies in 2 steps. This would be kind of a tricky thing to do in standard SQL, so this is going to be a good example of how views can come in handy. So let's go ahead and do that. Type along with me if you will. Create view, top movie IDs. So this says we're going to create a view called top movie IDs, and it's going to consist of the results of the following query. Select movie ID, comma, count movie ID, as rating count. And if you're new to SQL, just to kind of translate what's going on here, what we're saying is we're going to extract the movie ID and the sum of all the movie IDs from this table, and we're going to call that result the result of the count rating count. So basically we're going to end up with 2 columns, movie ID and rating count when we're done, okay? And rating count will consist of the total number of times that movie ID occurs in the data that we actually get back. We have to tell it where to get it from. It's coming from the ratings table. We're going to group by movie ID. So that way our count operation will count up all of the movies together for a given movie ID. It's going to cluster them all together. And you can kind of think about how this is going to translate into mappers and reducers, right? So, that group by is basically a reduce operation. And it's the magic of Hive that actually translates this SQL command into mappers and reducers for you. You don't have to think about it. Finally, we want to order our results by a descending order to get the most rated movies on top. And to do that, we say order by rating count and desk for descending order. Okay. So at this point, we're going to end up with a view called top movie IDs. It should contain 2 columns, movie ID and rating count. Okay, but we want names. We don't just want IDs. So let's go ahead and join those results from that view with our names table to actually get something human readable. So what we're going to way to do that: select n.title, comma, rating count from top movie IDs. We're going to call that T, join names n on t.movieid equals n.movieid. Okay, so let's talk about what that's doing here. Basically, we're saying we're going to kind of have to start here from the from clause. So it says that we're going to be using 2 different tables together here, top movie IDs, and we're going to call that the alias T, and we also are using the names table, and we're giving that an alias n. And by joining them together on the matching movie IDs, we can then map together those movie names to the movie IDs. And we can then do select n.title and rating count from that top movie IDs view. Okay, so basically instead of selecting from a table, we're selecting it from that view and extracting just the rating count and the title that was joined based on the movie ID. Okay, so that's going to give us our final results with human readable titles instead of ratings. So it's a good example here of using views. It's kind of a Hive specific thing, so I didn't want to just do a standard SQL query here. Okay, so now I should be able to just hit execute here and actually kick that puppy off, assuming I didn't type anything wrong. Make sure you double check if you are following along here. And off it goes. Now this is going to take a little bit of time. Remember, this isn't really a relational database, so things like joins are kind of painful when you're not really dealing with normalized data. Okay. So let's let that chug away for a few minutes, and through the magic of video editing, I'll come back when it's done. All right, we're back. That actually didn't take too long. And you can see here we have some reasonable results here. Star Wars from 1977 is in fact the highest rating movie from this data set. Again, keep in mind it's an old data set, followed by Contact, and then Fargo, Return of the Jedi, so on and so forth. So it worked. How about that? We used Hive and we used views in Hive to actually split up a more complicated query into something more readable and more manageable. Now, we're not done yet. We have to clean up our mess. So let's, if you click on the refresh button over here, you'll see that under the default database, we have that view in there, top movie IDs. And we should really clean that up. Now, there are ways of dealing with that. If we were to say create view if not exists, that would tell this script to this query to actually only create that view if it doesn't exist already. So otherwise, if you were to run this script, it would actually give you an error saying that, hey, this view already exists. But just to clean up our mess and not leave that around, we can say drop view top movie IDs, execute that. And you can see that sort of latency that happens with any Hive query is something you have to pay, a price you have to pay no matter how simple it is. Finally finished. Back to default, you can see it's gone now. So now we could run that query again if we wanted to. But there you have it. Actual results from Hive being run interactively from Ambari. And again, there are different ways of running that. Let's talk about what's going on under the hood in more depth in our next lecture, and some of the other ways that you can use Hive in more advanced ways.